Okay, so this video is going to go over pages 13 through 16 in your packet. So we're going to take a look at free body diagrams on this. So we're basically trying to figure out is what is the net force acting in these different situations. So in situation A, what you're looking for is you want to see if things are unbalanced or balanced. So if I look, I have a gravitational force of 3 newtons pulling it down. I have a normal force of 3 newtons pushing back up. Okay, so remember, normal force is just like if this object was sitting on a table. Okay, that normal force means that the table is pushing back on the actual object. That is called your normal force. Then I have an applied force of 5 newtons, okay, to the right, and I have a frictional force of 5 newtons to the left. So in this case, everything is nice and balanced out. So they basically all cancel each other out. So their net force, so F net, would be 0 newtons. Okay, so if everything's nice and balanced, that means this object is either sitting still or it's moving at a constant velocity. So both options are possible. Now, situation B, I have my gravitational force of 3. Okay, I have my normal force of 3, so those cancel each other out, so you're balanced there. Okay, but if you notice, I only have a frictional force pulling back on the object with 5 newtons, so there is no applied force. So this is not balanced out. So your net force would be 5 newtons to the left, okay, since it's pulling back towards the left, or you could say negative 5 newtons. Either way, as long as you give us some sort of direction, that's what we're looking for. Situation C, I have 20 going down, 20 of gravitational, I have 20 going up in normal. So this is balanced out, so my F net is going to be 0 newtons. Okay, situation D, I have a gravitational force of 25 newtons, and my air resistance, in this case, is going to be 40. So that means you've got this air resistance that's slowing you down. So it's overpowering the gravitational force. That's what's causing it to slow down. So we're going to find basically the difference. So 40 minus 25 is going to give me 15 newtons, and we're going to go ahead and say that's up. Okay, so that would be your answer there. Now here what we're trying to do is we are trying to finish out the free body diagram. So we're going to look at the 4 situations, okay, and see how do we need to complete them in order to get the net forces that we're given down here below. So in the first one, we want a net force of 0. Okay, so that means everything has to be balanced out. So if I have 200 newtons pulling down, that means I've got to have 200 newtons pushing back up. And if I have 50 newtons to the right, I've got to have 50 newtons to the left. Okay, so that is if a net force is 0. Now, the next one is I want 900 newtons up. So this one you got to be really careful. I see a lot of students, what they do is they'll say this is 700, okay, because they see this 200, and they say 700 plus 200 gives me 900. But you got to remember is this 200 is going against you. So what minus 200 would give you 900? And that would be 1100 newtons. Okay, so that would finish that. Your next one is you want 60 newtons left, so only left. So that means E, that bottom one is, it's got to be balanced because I didn't say anything about up or down. Okay, so that means this bottom one has to be balanced out. And if I want 60 newtons to the left, and I already have 80 newtons to the left, I got to figure out how do I get that down towards 60. Well, that means I've got to put 20 newtons going to the right to make it go to 60. Now the next one is we want 30 newtons to the right. So on this one, we didn't really give you an up and down force. So since I said net force, there's basically is no net force going up or down. You could honestly make that anything you want. I'm just going to say it's 10 newtons. Okay, but my goal is I want 30 newtons right. Okay, so if I have 20 newtons pulling me back to the left, that means I've got to have 50 newtons going to the right in order to get that net of 30 newtons. Now what we're going to do is we're going to take a look at Newton's second law. So remember, Newton's first law states that an object will remain at rest or continue traveling at a constant velocity unless an unbalanced force acts on it. So what we're going to do is we're actually going to look into that unbalanced force. Okay, so an unbalanced force on an object causes its velocity to change, which is acceleration. So anytime you're changing your velocity, you're accelerating either in the positive direction or the negative direction. So what factors will affect the rate of acceleration? So the greater the net force on the object, the greater the acceleration. So if F net goes up, acceleration goes up. Okay, and that's called a direct relationship. Okay, if one goes up and the other one goes up, okay, that is direct, okay, in their nature. So the way I think about this is you have an object. So let's just say this object, this is you sitting at a red light, okay, and you have another car that's coming up behind you, okay, and it's going to hit you with a force. Now you're sitting there, you're going to stop. You're sitting there at rest. Now that car, when it hits you, is going to make you move. It's going to make you accelerate. Okay, so if that object isn't that big, okay, then it's not going to generate very much force. Okay, so you're going to accelerate some, but not very much. Now, if I were to replace that situation, so let's get rid of the car that's going to hit you, and let's say there's a big semi truck that's going to hit you. Okay. Now what you're doing is you're generating that semi is going to generate a higher force when it hits you, which is going to make you accelerate even quicker. Okay, so if force goes up, your acceleration is going to go up, and vice versa. Okay, so I talk about this is if I walk into you, like if you're standing still and I just walk into you and bump you, okay, I'm going to make you move, but not very quickly. It's going to be some acceleration, not very much. Okay, but if I come running at you and you're standing still and I run into you, now your acceleration is my acceleration is higher, so that force when I hit you is going to be higher. Okay, so that is just a couple of ways to kind of think about that. Okay, and then the greater the mass of the object, the less the acceleration. So if mass goes up, acceleration goes down. That should make sense. The bigger the object it is, the harder it is to get moving and the harder it is to stop it from moving. Okay, so that is an indirect relationship. Okay, so if one goes up, the other one goes down. So you really got to make sure you know which one's which one's direct, which one's indirect, because that's what we're going to look into next. Now, before we get into more relationship questions, we're going to take a look at Newton's law, which is the law, or second law, is the law of acceleration. Okay, which is acceleration equals your net force divided by mass, or F net equals ma. Okay, so in this example, what is the acceleration? So you're looking for A of a 10 kilogram object. I just gave you mass, and has a net force of 25 newtons, so I gave you force. Okay, so you got to make sure if you don't know how to label things, what you have, it's going to make it a lot harder for you to solve these problems. So we're going to use our equation. So A equals F net over M. So A equals 25 over your mass, which is 10. And you're going to get 2.5 meters per second squared. Okay, and we got to make sure we're looking at this is if the force was acting to the left. So that means my direction is going to be left. And you can spell it out if you want to. You don't have to do the brackets thing. Okay, now your units for force. We've already talked about this is your newtons. It should make sense since we're talking about his laws. Okay, now newtons is technically force. Okay, mass would be kilograms times your acceleration, which is meters per second squared. So technically, both of these things are equal to each other. Okay, it's just easier to write newtons. Okay, now if you're doing the calculation, if you're doing A equals F net over M, and you're like, how the heck does meters per second squared come out of that? Okay, well if force is newtons and mass is kilograms, okay, well that doesn't really look like meters per second squared, but technically that would be the same thing. Okay, what we're going to do is we're going to plug in this what we looked at up here for newtons, so kilograms times meters per second squared, and that's still over kilograms. So kilograms would cancel out, so all you is you end up with meters per second squared. So that is how we actually get meters per second squared from taking force divided by mass. Okay, so don't worry too much about that. That's just how you do it. Okay, now we're going to do some basic math. Okay, so we're going to do some basic force calculations. So it says determine the acceleration, so A, okay, which results, so A is your question mark, which results in a 12 Newton net force, so there's my force, is applied to a 3 kilogram object, so there's your mass. Okay, so I'm going to plug in, so now I like to use this, so you can do A equals F net over M if you want to. Okay, I always do F equals MA. Either one is fine, okay, whichever one you prefer. So my force is 12, okay, my mass is 3, and A, that's what we're looking for, so 12 divided by 3, and you get an acceleration of 4 meters per second squared. Number 2, a net force of 15 newtons, so I gave you force here, is exerted on an encyclopedia to cause it to accelerate at a rate of 5 meters per second squared, so I just gave you A. Determine the mass of the encyclopedia, so you're looking for mass. Okay, so we're going to do F equals MA again, so 15 equals M times A, which is going to be 5. So 15 divided by 5, nearing a mass of 3 kilograms. Number 3, a bowling ball is released with a constant velocity of 5 meters per second. So key thing here is constant velocity of 5 meters per second. What is the net force to keep the ball moving at this velocity after it's been released? So remember, constant velocity, you've got to make sure you pay attention to this term. If constant velocity is 5, so it means it's not changing, that means acceleration equals 0. If you are not accelerating, okay, or if you're going to constant velocity, that means you have 0 acceleration. Now, if we look at the equation we just learned, so F equals ma, if A is 0, then F has to be 0. It doesn't even matter what mass is. Anything times 0 is 0. So that means F net is going to equal to 0 newtons. So there is no really calculations for this one. Okay, you just got to make sure you're paying attention for that term. If you see constant velocity and I ask you about force, okay, then your net force will be 0. Last one, number 4, a net force of 25 newtons, so there's your force, is exerted on a rock to cause it to accelerate at a rate of 2.5 meters per second squared. So there's your A. Determine the mass. So we're looking for mass. So 25 equals your mass times A, which is 2.5. So divide both sides by 2.5, and you get a mass of 10 kilograms. And that's it. That'll end that video.